Hi everyone, it's Mrs. Brimlow, and today I'd like to talk to you about the real number system. So, our first unit for the year is the real number system, which is something you're familiar with. There are numbers you've been working with since you started working with math. We're going to focus today on the difference or the two main categories that make up the real number system. So, if you have a copy of these notes, I'd like you to take the notes along with the video. If not, you can watch the video, get a copy of the notes later. For these notes, I will be using a pen or pencil to write with, so you'll need that, and then just one highlighter so we can highlight some important information. Okay. So, once again, we work within the real number system, all the numbers we use on a daily basis. And the real number system is made up of two categories: rational numbers and irrational numbers. Okay. So, a rational number is a number that can be written as a fraction of two integers, except for 0 in the denominator. Okay. So go ahead and pause this if you need to catch up, and then I'm going to go ahead and highlight. So once again, I really want to emphasize or highlight that rational numbers can be written as a fraction. Okay? When I use the word integers, that means positive or negative whole numbers, with the exception of having 0 in the denominator. We can't divide by 0, and fractions are just division problems. So 0 can never be in the denominator. It could be in the numerator at the top of the fraction, but not in the bottom. Okay. So whether you're working with a rational number or what we'll go over in a second, irrational number, they can be written as decimals. So we're actually not going to draw a picture. We're going to describe what the decimals would look like. So decimals will terminate, which just means to end, or repeat a pattern forever. So decimals will either terminate after a certain digit in a place value, or they go on and on forever, but there's a clear pattern that you can see. Okay? So it's going to be either or when we're talking about rational numbers. I'd like you to pause and see if you can think of any examples of rational numbers and list them compared to my list and update yours. Okay? So the definition literally says can be written as a fraction. Therefore, fractions and mixed numbers would be included in this category. Okay. We can also include decimals that terminate, for example, 0.5 that ends at the 5. This is a terminating decimal, and that can be written as 1/2. Okay. We can also have decimals that go on and on forever, such as 0.7, and we know it's repeating because it has this bar notation, or it would look like this, with some dots showing that the pattern goes on forever. So this is a terminating decimal. This is a repeating. I'm going to write T and R. Okay. Some other examples would be, once again, positive or negative whole numbers. So let's do positive 9, and that can be written as a fraction of 9/1. We could also have negative 2, because that could be negative 2/1. 0 is also included in this because we can write it as a fraction of 0/1. 0 divided by 1 would just be 0. Once again, you can have 0 in the numerator, but not the denominator. Okay. Another example I'd like you to put down is this. This is how you would read this is the square root of 9. I want you to take a minute and look at a calculator and type in the square root of 9 and see what you get, okay, and then come back. What you should have gotten is 3. We know that whole numbers can be written as fractions. We saw it here and here. So when you take a square root, such as this, and it comes out to a nice whole number, it's going to be rational. Okay, so I think we've covered everything here. So let's talk about irrational. want you to go ahead and try the square root of 2. Okay. What you should have found is that it comes out to a decimal 1.414213 dot dot dot, depending on how many digits your calculator can fit. There's no clear pattern here. Even though we see 1 multiple times, 4 multiple times, it's not the same as 7777 repeating over and over again, or 121212. It's not clear, and it goes on forever, even though it stops on your calculator because it can only fit so many digits. So when I see a square root that comes out to this crazy decimal, that's going to be irrational. And most of them are irrational. There are only a few that are going to end up in this rational category. Okay. And that also leads us to our decimals. When they don't come out to either terminating or repeating a specific pattern forever, they're going to be irrational. And then probably one of the most famous is pi. They have not found an end to pi yet, so that is still considered an irrational number. Okay. So once again, we have our definition, we have our decimal form, we have some examples, and then these are our non-examples. Okay. So let's go ahead and move down to irrational numbers. So basically, a number that is irrational, IR, means the opposite of rational. So that means it's a number that cannot be written as a fraction. Okay. Just go ahead and pause this if you need to catch up with the definition. Then I'm just going to highlight it. Cannot be written as a fraction. Those are irrational numbers. Okay. We're all set with the highlighter for now. So once again, we're not drawing a picture, we're going to describe decimal form. So decimals will go on forever without a pattern. So the nice thing here is we really don't need to come up with any new examples. We already have what we need, except in this case, we know these are rational, so they're not going to go in the example situation. They're going to go in the non-example. So basically, we're going to flip this. So for our examples, square root of 2 would be an irrational number because when I type that into my calculator, I'm going to see that it goes on and on and on forever with no pattern. Same thing with pi. Okay. So my non-examples, or numbers that are not irrational, meaning they are rational, would be 1/3, 9, 2 and 7/9, -2, 0, square root of 9, 0.5, and then 0.7 with the bar over it, meaning it repeats. Okay. So today what we're going to do is spend some time practicing categorizing numbers as either rational or irrational. These are terms we're going to be using a lot throughout our unit, so we want to be very comfortable with them. So if you flip to the back, if you have this paper, you can do this sort. You're going to take all these terms in numbers and sort them as either rational or irrational, or you can check Canvas to see what I have prepared for an online activity. If you have any questions, reach out, and thanks for watching.